Well, a while ago I did a tear down and review of these cheap and crappy AC panel meters which show voltage and current, and while they seem pretty good for voltage, the current was well dodgy. I've also got these other meters, slightly upmarket, and there's another one on this dummy load box, and these others show energy and power as well as voltage and current, and sometimes even power factor and frequency, and all of them are pretty good for voltage as I remember, but I wanted to, they never seem to agree on current, so I've been working towards being able to assess their accuracy on current measurements, hence this mess. Now, I originally set this up using this resistor as a current measuring element, and it was a bit naive. It's 0.1 ohms roughly of manganese wire, and 0.1 ohms too high, it gets too hot, so I went onto a side track of making this higher power resistor, which is at about 10 milliohms or 100th of an ohm, which is probably about the right value to get decent accuracy without having to deal with extremely low voltage measurements across the resistance. And I went off on a side track of accurately measuring this, and now I know that it is 11.6 milliohms. So I'll put this in place of that thing. Now, I was using these resistances to measure current because I forgot that I also had some HP 3468 multimeters which can measure current. Because of this shitty LCD display with no backlight, I never use them. I forgot I had them, and that they can measure current. These bigger HP meters can't do current, so yeah, but even so, this is only good for 3 amps, and I want to test this stuff up until about 10 or even 20 amps by putting loads like that toaster oven and this oil-filled heater contraption, and I can get up to about 20 amps of load that way. So I'll try and explain this mess. All this stuff here, well, first of all, I've got Variac and my high power isolation transformer, so that all this stuff is isolated from the mains. So trying to explain this mess, one side of the transformers goes to this terminal. The 2 outside terminals on this go to the power point. The middle 2 do nothing, so these 2 are just a junction between the 2 transformers. That's effectively the centre tap of the combined transformers. The other side of the transformer goes through all this to measure current and returns here. And the red and the blue wires are for the voltage sensing on these meters. So this would connect there, or through the resistance, but I'm going to replace that resistor with this larger one, and I'm going to include the HP 3468. So I could set it up like this, for instance, measure the current that way. And in fact, I've got 3 of these things. I might put another one there so I can see how closely the 2 HPs agree as well. Now that power point goes to this dummy load box, which consists of a couple of light bulbs, so I can get about 225 watts out of that. But there's also 2 power points down here, so I can switch in the toaster and that oil-filled heater as well to increase the load. And this meter will show the voltage and current consumed by that load. But all the current stuff's in series, so all the meters should agree on current. When I've got everything, all the loads switched off, there shouldn't be any voltage drops except very small ones in the current sense resistors, and so all the meters should agree on voltage as well. These 2 little panel meters here and this one use current transformers to sense the current. That's what they are. The one in the dummy load box and this one here have internal shunt resistors to measure current. Believe it or not, all these things are in series current wires and in parallel for measuring voltage. I'll show you the schematic for that lot. Yeah, so Variac goes into the 2 transformers that form an isolation transformer. There's that centre tap on the terminal on that PowerPoint wooden thing. Plugged into that PowerPoint are, well, there's the 2 bulbs. There's the meter internally that senses the voltage and the current. And these are the toaster and heater dummy loads that I can add to the light bulbs. Then the return goes through the 3 current transformers, through the sense resistor in the 4th meter, through my homemade sense resistor, and back to the transformers. And I'll also stick the HP meter in there, or 2 of them. So that's the schematic. If we look at it for how they measure voltage, so if you can treat red and blue as positive and negative, I mean, I know it's AC, but you know what I mean. You can see how this meter gets his voltage sense across there, same with there, and there, and there, and there. And for current sensing, goes through the 3 loads, through the sense resistor of the meter in the dummy load box, through the 3 current transformers, through the sense resistor in the 4th one, through my sense resistor and the HPs. I hope that's clear as mud. So I'll wire this thing in, put in the second HP, and we'll continue from there. Alright, I've tried to fit everything in shot. There's a lot of digital displays to look at here. I should mention also, although at the moment we're looking at these 5 meters here with digital displays, I've also got this thing, which is another similar to that one. It does the voltage, current, energy, power, frequency and power factor, but its output is not a display, it's a serial connection. So I'm going to play with that connected to a PC to monitor what it says, but in a later video. I won't bother with it in this one. But and I should also say, all these ones that use a current transformer are rated at 100 amps, and these 2 which use a internal current sense resistor are 20 amps. Now, what are all these displays doing? I sat them on top of these so that we can get a look at the displays in these HPs, and I hope that one's readable. I hate these LCD displays. These are both current, showing the current through the circuit. These of course also show current and voltage. I've put in my big resistor to replace this one. The bottom HP at the back is showing voltage, and the top one is showing the voltage measured across this resistor, and it's been set up to divide by 0.0116 or ohms. So although it's measuring voltage, it's displaying current. Voltage divided by resistance gives current, Ohm's law. So let's just turn on, slowly powered up by the Variac. I'll disconnect these 2 light bulbs so that there's no load at all, so we can just check the voltages then, because there won't be any voltage drops. Winding it up. Now these come on pretty early. They only need 30 odd volts to start working. The others need more like 80. Starting to work. 70 volts. 80 volts and they're working. So let's take it to 100 as measured by the meter at the back, the HP at the bottom, and see how they agree. This one's saying 98, 99, 97, 99, 99, all pretty close on voltage. And 150, 147 is a bit low, 148, 145, 148, 147. So they're all reading a few volts low, this one being the worst. 200 volts, 196, 197, 194, 197, 196. So again, this one's the worst. But that's even that one's within, what, 2%, isn't it? It's about 3% out. The others are within 2%. And finally 250 volts, 246, 246, 242, 247. So they're within 4 volts, and 1% would be 2.5 volts. So they're within 2% on voltage, except for this one. Alright, now I'll wind that down. Now remember, I can only put 3 amps through this circuit with these 2 HP meters, so just turn on the bulbs first. So now they're plugged into the circuit, so winding the voltage up again, and the bulbs are starting to light. Let's take it to 100 volts. And the current, so these things, as I discovered in the previous video, they don't even work till there's 0.7 of an amp running through them. According to this, we've got 0.53 amps, 0.536, 0.53, 0.54, 0.54 and 0.56. So my supposedly accurate current sense resistor is disagreeing with these 2 HPs, which I suppose are the most authoritative measurement I have here. And although they're not the calibration state of them is unknown. The fact that they agree pretty closely means I think we have to take what they say is the most accurate. Okay, I'll take it up to 150 volts, and these still haven't shown anything. 0.66, 0.666, 0.66, 0.673, can't read that one, 0.674, and my resistor is still measuring a bit high, 0.698, 200 volts, 0.77. Now these are starting to work, although I've only got 2 digits of accuracy there, 0.779, 0.79, 0.79, and this is still reading too high. So in fact these things here seem to be more accurate than my current shunt. 240 volts, which is the full rating of these bulbs. They're supposed to be 225 watts at 240 volts. Only getting 199. Well, yeah, they'll say about 200 watts, but it's 150 watts and a 75 watts, so it should be 225. Alright, now to measure currents higher than that, I'm going to have to turn on the space heater down below, the oil-cooled heater, and reduce the voltage, because that will draw more than 3 amps. So to get between 0.8 of an amp and 3 amps, I'm going to have to lower the voltage and turn this thing on. So volts down first, and turn this guy on. Let's take it to 100 volts. 100 volts, we got 2.37 amps, 2.2, 2.1, 2.33, 2.33, 2.32, 2.32. And again, my meter up the top is too high. So what I can do is change the number that I've entered into this thing for the resistance of that. If I change it to 11.91 milliohms instead of 11.6, so 0.01191, still there. That's more like it. They agree more with the HP. So assuming these two HPs are accurate, now that's been adjusted to meet these same current as these two. And can't go much further, can I, with those? So what I'll do now is take these out of the circuit so that we can increase the voltage with this load and draw more than 3 amps. Alright, we've taken these two multimeters, the HP 3468s, out of the circuit, and now it's just the only current measurement apart from the meters that we're testing is the homemade resistor over here. And I've still got that corrected value stored in here, which seem to make it line up more equally with the HP 3468, so I'll leave that in there and assume that this is actually 11.91 milliohms rather than 11.6. Okay, winding up, and I've got the toaster oven down there and the space heater both turned on and switched in, so plus the bulbs, so winding up the voltage. Let's take it to 100 odd volts, 3.14 amps. These are reading low, 3.077, 3.07. So these two are in pretty good agreement with the HP at the top there. This one here is reading a bit high, 150 volts, 4.48 still high, 4.39, 4.37, 4.38. So these two are in pretty good agreement with the top meter. These things are reading low, 240 volts, 200 volts rather, 5.67 amps, 5.6, 5.6, 5.8. So this one reads high. These two are again in agreement with that. And finally 250 volts. Now here, of course, remember that the voltages being lower here than there could all be due to voltage drops in the wiring, which we didn't have at the start where I had no current running with the bulbs disconnected. But now you've got to remember that these could be low because of voltage drops. But the current should agree, because that's common to everything. And 6.95, 6.99, 7.8, that's 7.18. These are low. I feel like this one can be trusted the most. That's just a guess. In the absence of better, more accurate, calibrated instruments, this is probably the best I can come up with. But as you can see, the current on these two certainly is within better than 1%. These are bloody hopeless because they don't even work till there's 700 milliamps running, but this meter here and this one here are of the same type. I think I bought them at the same time, so yeah, it looks like a bit of variability in these things. And I guess you could always get into these, certainly with their built-in shunt resistor, and put in a trimmer or something to try and calibrate them. And I guess you could do similarly with the burden resistor that's connected to the current transformers on these guys. So that's probably enough for this. 1.7 kilowatts, everything's getting a bit hot. In summary, what can we say? These are crap. This looks pretty good. These are not bad. There does seem to be some variability. And I've got another one of them up on the Variac, and it shows different numbers again to what this one shows. What are the model numbers on this? This is a PZEM022. This is a PZEM021. These things I don't care. And the other one that I'm going to test in another video is PZEM004T. I hope you found that vaguely interesting, vaguely useful. These I wouldn't bother with unless you're only interested in the voltage, or you've got a very consistent, reasonably high current and you don't mind it being 5% out. This looks like the best. These aren't bad, but this one also shows power factor and frequency. The power factor I can't really test very easily here. I can stick in like this is all resistive load, so it's always power factor 1. I've stuck in, say, a CFL or a LED bulb and the power factor changes, but I've got no way of knowing whether or not it's reading it correctly. Okay, I think we'll leave it at that. Catch you later.